Hello friends. As promised, this is a video about breaking down a monolith into microservices. I spent a really long time writing this code, a really long time on this split. Well, relatively long. I plan to do it much faster, so I won't put it off any longer. Let's get started. For me, the most challenging part was not the splitting itself, but rather configuring the components and setting up their interactions with each other. That is, the division itself, it shouldn't present any particular difficulties, well, in my opinion. That is, everything is logically clear there. But when it comes to separating things out, I definitely had to think about it. Let's take a look at the scheme we'll follow today. So first, we'll take a couple of minutes to remember the project we worked on before. A link to the previous video will appear somewhere here. Second, we'll look at the indicators for splitting and how this splitting takes place. Third, we will split our monolith into microservices. And finally, we'll set up the interactions. Let's get started. So friends, what did we do last time? Last time we created an application like this. It consisted of 3 modules: library, start, and statistics. So this is the monolith, and inside it, there are modules that communicate with each other. So the start module launches all the main components, the library interacts with the user, and the statistic module collects statistics. We used an event-driven architecture for the library. Let's take a look. We have it right here. There was this bin, and it's still there now. The application event publisher, which publishes events, it passes on its statistics. Listener, this is our application. So what are we going to do with it now? We're going to split it into microservices. So friends, take a look. This is our monolith. One database, all the modules together. In short, you all know this already. Now let's take a look at an important part. What are the indications for splitting it up? And you'll see something interesting right now. If you go to our file and look at what indications and strategies we have, it turns out that we never actually use, just as we never use one pattern, we also never use just one strategy. Isn't that surprising? Look here. First, let me do it this way, so that both the Russian and English versions are visible. First, gradual replacement of the monolith with microservices, where new features are implemented as separate microservices. So basically, we're going to take each of our modules and extract it. Here's our gradual replacement. Okay, all new features are immediately broken down into microservices. Well, that's certainly very good, but we first created a monolith, then a microservice. It's like a strategy to write microservices right away, but it's still a strategy, creating a gateway that routes requests to the monolith. And this is also our case, because we will take the starting module, and it will serve as the entry point into the program, accepting all requests. And the starting module will distribute the requests among the modules, deciding which request to send to which one. We'll write that down too. In terms of domains, authorities where each is responsible for its own business logic, well, it might not be exactly our case, but we've already split it by business logic. We've already divided it into modules. There are monoliths that aren't divided into modules, and in that case, it's harder to extract certain components and make decisions about which specific logical components to separate. Based on functional modules, also our case, translation boundaries, we have a separate database, so I can't say that this is exactly our case. But, for example, organizing microservices around events generated by various actions is also our case, because both the library and statistics differ in terms of business logic and events, as the library sends some event to the statistics module. Please, the same applies here. Breaking down monoliths into microservices, based on technical layers, for example, front-end, back-end, or database. Well, at the database level, we will also split them, so we can say this is our case. So, what will we end up with? So you see, here it's all like in life, basically. It's all the same. It's all like in life, basically. It's all the same.
We'll set up Docker with separate services, library, static. As a result, we will have a separate library service, a separate jar file, a separate static service, a separate jar file, API gateway. This is our starting module. A separate jar file, a separate RabbitMQ will be located. Server, a separate database for the library, a separate database for statistics, and all this will be transmitted in Docker containers via internal ports. We will set all this up. Create a docker-compose file, write down all the actions that need to be done. Press 2 buttons and see how it works for us. Let's get started. We'll start with this. We will take the start module and turn it into the API gateway. What is that? The API gateway will be a separate microservice that serves as the entry point to the application. It will distribute requests, directing them to the appropriate service based on the incoming request. So for this, we will need Spring Web to run the application on the Tomcat server, and we will need Spring Cloud Gateway for the configuration. Basically, that's it. We will write all the configurations in the application.yml, where we will also specify where we will be redirecting everything, and that's it. Basically, we don't need anything else. We will also need a Docker file since everything is stored in Docker, but it will be a simple Docker file that will just build it. Yes, so docker-compose will be the one to run all of this, and it will also set up the network. Let's get started. So here is our Monfile new project. Here is our demo project, Spring Boot on the event collector. Okay, jar 17 Java. So this will be our copy service and support for your various needs and requirements. So the copy service next has been successfully integrated into the system. Additionally, the Spring Web framework has been added to enhance web functionalities. Furthermore, the gateway service has been incorporated to manage and route requests efficiently. Finally, the process to create these integrations has been completed. To continue with our tasks, it's crucial to keep the old project open. I won't close it now and have moved it to another screen. This way, we can easily access it whenever needed, ensuring we have all the information without disrupting our workflow. So that's it. Everything has loaded for us. Let's take a look. Here is a regular project. It's empty. There's nothing interesting here. What is this? There's nothing interesting here. Let's see if there's anything interesting here after all. So the main method that will run our service, great. Basically, we won't touch it. Next, let's take a look. Resources, static. We don't need the static folder. There won't be anything there. Templates. There just won't be anything there. Application properties. Let's delete. Slime. We don't need it here. And we do a refactor. Let's convert this to YAML format. YAML refactor. Great. We don't need the test folder. Next. POM.xml. Here it is. POM.xml is the most interesting part. So let's see what we have here in POM.xml. As in the previous project model version, the Spring framework is our main one. Let's take a look at the group ID. We'll remove com.app.app.service.name.app.service. Disparition. Next, this part is not really needed. We don't need this part because it deals with license. Okay, properties. In Java Spring Cloud, we have starter web. 17. Okay, we have the starter. There's a gateway. Great. Starter test. We need test here. We need it here. So dependency management, Spring Cloud. Okay, all right. Dependency management, basically this line isn't really needed here either. We can just transfer the version. We actually need Spring Cloud Starter Gateway. Not just a gateway, just not the gateway. And let's just remove this thing from here too. And we'll put it here. We will, what's there? Oh, 415. Wonderful. That's it. Done. Let's also remove this. Guys, I will definitely upload this code. Moreover, my code will have comments above each line. Basically, you can download it and see what each part is responsible for, what everything is written for, and so on and so forth. So please like and subscribe. This will be better than your gratitude. Let's continue. Let's update Maven and see if it pulled in the dependency. You know what else I love to do? Download the source and documentation in case you need to dive in and read the documentation. It's better to pull it in ahead of time, so we've got that sorted out. The next point, application YAML. It gets really interesting. So application YAML, Spring main banner mole. Let's disable the banner. We don't need it here. Next, Spring Web Application type, reactive. This is already a very important part. What does reactive mean? The reactive line in our API gateway indicates that our application is using Webflux. It's a framework in Spring. It's very important for several reasons. First of all, it allows us to work in an asynchronous, called non-blocking mode. This means that we can handle a larger number of requests simultaneously without waiting for each one to finish. For example, we will use RabbitMQ, but for transmitting messages between microservices, our configuration is reactive. It allows the same message to work without a blocking thread. So this means that our API gateway can send and receive messages from RabbitMQ at the same time. Do you understand? But that's all about speeding things up. So this is an important part. So let's move on. We figured out the main part. Okay. Cloud. In the cloud, we have a gateway, and the gateway, we have something called routes. I can't see it. Routes. Here, I see it. What does routes do? Routes define the route for the service, where it will send it. So we need to specify the ID of our service. Our microservice will send a request to the library service. If we are going to send a request to the library service, when we set up the library service, we will specify all the IDs and various identifiers there. But here we just need to set its ID because it has to be there. So routes define. Damn, where are we? ID. The library offers a wide range of services, including book lending, access to digital resources, and community programs, all designed to support learning and personal growth. Done. Next. Where is it? Oh, great, you're right. Let's do it all like this. Something is throwing an error. The URI specifies the address of the service or the port on which it is running. So, since our gateway will be inside a Docker container that directs requests, it will be to another service, which will also be in a different Docker container, but in the same Docker network. And the access to Docker containers happens by the name of the Docker container. So here we need to specify the following. HTTP, what's next? What's going on? / and all that, right? Dumb. Where's our slash? You know, no. We have a reverse solidus, like this. And the name of the Docker container will be library service. And accordingly, what will the port be? The port will be 8080. Okay, we wrote it down. Next. Predicate. The predicate tells us how, that is, the address to which we will specifically send requests to this library service. So, in order to specify this, we write PF. I have a Spanish keyboard. And then everything that we will have with the prefix. We will have two prefixes, like this one, library, asterisk. Where's the asterisk on this keyboard? And then everything that we have with a prefix. Here we will have two prefixes, like this one, library, asterisk. Where's the asterisk? And where is it on this keyboard? The asterisk is the number 8. Asterisk. In this way, thus, it defines the so-called routing predicate, which redirects requests that start with library and something else to the library service container, where the library service module will be located. So that's basically it. The next point, filters. So in the filters, we will apply filters that remove the first segment of the path, which in our case is library, from the request, right, before sending it to our target service. So it will be written like this, where we have, yes, everything is working. So regarding the strip module, next, we do prefix equals 1. So we are removing one piece. Okay, good. So all that's left is, we don't need anything here. We can write server port 88 so that everything will work here. Okay, we figured that out too. Let's check one more time. So here we have, everything's okay, all the dependencies are there. We've written everything here, everything's good. We've written everything here too, everything's good. Okay, let's assemble it. We've written everything here too, everything's good. Okay, let's assemble it. Let's assemble and package it. Oh, I forgot to do something, I forgot. Okay, let's pause. Stop. What's going on over there? Nothing. Look, here's what we need to do. We need to do the following, since we will have an API service. Here it is. It's called the API service. API service. In order for it to build properly in Jarmix, we need to specify something in the build during the build process, that its name will be API service, like this. Let's rebuild it, or rather, let's update it in a way that suits our current needs. Let's take a moment to discuss the process of packaging. Packaging is an essential step in ensuring that products are protected and presented in an appealing manner. It involves selecting the right materials, designing the package to fit the product perfectly, and ensuring that it is sealed properly to prevent any damage during transportation. I've already completed the packaging process for this item, which means I've chosen the appropriate materials, designed the package to enhance the product's appeal, and ensured that it is securely sealed. This not only helps in maintaining the product quality, but also enhances its marketability. Proper packaging is crucial for both the safety and attractiveness of the product. All right, everything's fine. What else do we need to do? Look, new file, Docker file. So we need to write a Docker file in which we'll specify how it will be deployed inside the Docker container. This file is crucial for the deployment process. It contains all the necessary instructions and configuration. Additionally, it ensures that the application runs smoothly and efficiently within the container environment. Images and so on. There will be 5 lines. You all know them well. They are all familiar to you. First, using the official coconut. Yes, we need to scroll. What's going on over there? Open JDK. Yes. We have version 17-alpha OTP, something like that. JDK 17, yes. JDK. Okay. To be continued. We have loaded the image. Next, we need to install something inside the Docker container. So if we think of the Docker container as a box, we want to put something inside that box, and we want to create a compartment there. This is the working directory where our application will be located, deployed. So we just need to name it somehow. Let's call it app, not that. Now we will start like this, app/app. So there will be a folder like that. Perfect. Next, we need to install the curl utility to make HTTP requests. We'll need it. To execute the curl command, we begin by opening the terminal. Here, we will carefully write the necessary command line instructions to perform the desired operation. This process involves specifying the correct parameters and options to ensure successful execution. So we need to rewrite this. In the following steps, we are going to proceed with the installation of a very useful tool called curl. This utility is essential for making HTTP requests, which are necessary for various web-related tasks. To install it, we will use the package manager command apk add no cache. This command ensures that the curl utility is added to our system without caching any unnecessary files, thus keeping our system clean and efficient. By doing this, we enable our system to form HTTP requests seamlessly, which is crucial for interacting with web servers and API. Okay, no, just curl, that's it. I think it should be like this. Next, we need to take our compiled file from the target and move it to the working directory. Copy it over. That's the sequence. Copy. We're taking it from our target folder. So the name of our application is app service. We carefully pick up the object, ensuring a firm grip, and proceed to move it to the designated spot right over here. It is crucial that we place it precisely where it needs to be, without any errors or misplacements, as accuracy is of utmost importance in this task. This careful handling and placement ensure that the object is positioned exactly as required, maintaining the integrity and purpose of the task at hand. Service jar. I think it should be like this. I forgot to add jar there, you see, and I actually have an equal sign just a little bit. Okay, all right. The next thing we need is to open a port for access to the application running in the container. This is done by the Apex Pulse team, port ANIA by 8081, because we will have a host port, that is, where we will be accessing, and a port for the service within the network. They will be different. I'll show you a bit later when we create the docker-compose file, and I'll explain it at that moment using an example on the overall picture. You'll see here, so we will have those where the external one should be, meaning there should be some external port, and there are internal ports through which they interact with each other. So we need to set up the external. Okay, so basically at the end we have this thing called entry point. It defines the command that will be executed when our container starts. Yes, entry point. There will be something there. Java, a popular, versatile, and widely used programming language. -jar, and we are building our API service. Change the jar, and we are building our API service. It's very hot and gathered. The conversation is okay. Point. But basically, everything seems to be ready. All right, this module is ready. Let's package it. Write in the comments what the difference is between package and install. Copy target office service jar. Absolutely perfect. Now that we have successfully completed this section, let's smoothly transition and proceed to the upcoming module, which will further enhance our understanding and skill. So, library service, new project name and library service. Great, everything is there, everything is there, everything is there. We have Java, okay. All right, so what do we need for our library service? Well, first of all, since we have controllers in the library service, as you remember, interacting with databases and all that stuff, what do we need? For the main method to run it, we need that server to actually work, in its main part. Got it. A starter package for working with the database. Next, we will need, accordingly, RabbitMQ. Where is RabbitMQ? Same here. This will be our message broker. We will also need a logger. I respect that this will be our message broker, and we will also need a logger. For all kinds of annotations, we will also need them. We will have a MySQL database, so we will need the MySQL driver. And here, interestingly, there's Jackson data bind. No, it's not here. Well, who knows? Maybe it's here after all. All right, we will need that too, by the way. We'll add it later. So create. Let's leave it without the service for now. Now I will move it here. Quick loading. So guys, let's quickly go through the POM file that we have. Let's update it. I quickly added a few dependencies like Jackson data bind and so on. I got them from the Maven repository. I'll leave the link somewhere. I need to provide the link. So let's take a look at the library service. All right. Let's start with the POM, since it's open. So module version is okay. Parent Spring Framework boot is okay. Okay, good. COM app library service snapshot. Name description. Let's remove all of that. We don't need the 17th ball. So look, I left a comment here, and accordingly, in the other module, when we write it, I'll leave similar comments. Well, it's written here what we will need. The starter package, well, by default, it gets delayed. For web applications, GPI for databases, RabbitMQ, MySQL Connector J, our Moodle driver, Project Loan Book for the code. And here we have Jackson data bind for working with JSON data, serialization, and deserialization of objects. And why do we need serialization and deserialization of objects? We're going to pass an object. If you remember from the last video, the book-oriented event with a network. So we need serialization and deserialization of objects. And accordingly, the module for supporting constructor parameters, the parameter names module. Here they all are. What else do we need to do? We also need to do this. Look, we need to take this name library service, Ctrl+C. And in the build, file name, add the name library service. Next, we take maxml, Neve, download service documentation. Now he will quickly take care of everything. I'll also press the button, just in case. The sun and the button for this, let's also make our home just in case. The next point, let's move on to our API service Docker file. We'll definitely need it here too. We'll just copy it. The only thing we need to fix is to make it a library service, not an API service, right? Look, I think we have it serialized here. All right, I copied something. Library service, library service, library service. Okay. The only thing we might have questions about here is the port, but everything seems to be fine with the port here. Everything is done here. All right, let's move on. Main, Java, okay, library service, a great resource. We don't need static. We don't need templates. We don't need the test. Okay, what are we going to do next? So guys, we're in our good old monolith. Now we need to take all these folders that are here, just Ctrl+C, and transfer it successfully right here. They'll coexist nicely here. Transfer it successfully right here. Here they will coexist nicely. We'll take care of them separately a bit later. Let's prepare the application refactor linear by ensuring all necessary components are in place and ready for deployment. This involves checking configurations, dependencies, and system requirements to guarantee a smooth and efficient process.
Ready.
Let's go to the application pit. Let's delete this line. Everything is fine. And now we need to do the following here. Look, Neo, not like that. Look at what we can do and observe all the incredible and amazing things. We'll open the starter module, src resources. And here we have the database, C, Ctrl-C, copying. We paste it here. Why are we doing this? We're doing this to create a separate database for library service. And all of this is so that when we launch this service, these scripts will run, but these scripts will be modified. We'll create a separate database for this module. Separate, we'll just change them, and that's it. Let's take a look at how they look right now. Okay, the SQL schema and so on, drop table and so on, creatable user, creatable books, creatable statistics. So basically, in reality, we absolutely don't need this part here at all. It's completely unnecessary and absolutely redundant. We don't need the statistics here either. Let's connect to the database. Configure database to the system setting. Since he's asking like that, as he is curious about the process and wants to understand it better and wants to know more about it and is eager to learn more about it. MySQL, I've already created such a database, so please create it in advance. But this will be new for you. 1, 2, 3, 1, 2, 3. Okay. What is it called for me? lib1. That's what my database is called. It seems so. We tested the connection. Everything works perfectly. All right. Apply. Okay. Let's take a look. The SQL schema. Okay. Everyone is perfectly satisfied. There's a schema, there's data, statistics. We're removing it from here. Everyone is perfectly satisfied. There's a schema, there's data, statistics. We're removing it from here. Here, let's also make the library work so that everything runs smoothly. Everything's green, perfect. All right, now let's move on to the application YAML. So the application YAML, look at this beautiful shell. I left a comment here about what this is for and how it works. I copied it, decided not to write it out because basically it's all the same. We're disabling the banner here. We're saying that Hibernate isn't doing anything, showing the queries, and specifying which dialect, the MySQL dialect. This is important because when running the application in containers, it can sometimes be different in this regard. Next, we always initialize the schema at this address that we set up here and populate it with data at the same address. It's all the same as what we did in the previous project. Then always initiate the scheme at this address, which we made here, and fill it with the date at the same address. We did the same thing as in the previous project. The only thing we've added here is that the server runs on port 8080 and RabbitMQ. What's important here is that the port is by default, the username and password are guessed by default, but the RabbitMQ host is, in fact, the name of the container that will be there. That's what we decided to name it. Okay, now let's move on to more interesting topics, like what's going to happen here at the level of controllers, entity event, and so on. Let's take a look at what we have here in the controllers and how they actually look. We copied these folders here. We probably need to take the book service from here, right? Book client event. Please import cost. It's all the same as in the last project. The book will stay the same. The user will stay the same in this particular context. The event will stay the same too, as it currently stands, without any sort of changes or modifications. Repository. So we have some issues with the folders here. Let's delete it and import it again so it doesn't throw any errors. Okay. JPEG repository is good. Services. Box service. Let's take a look at what we have here. Incorrect import. Why? Is it not working for us in any way, perhaps even more so? Got it. Everything is working perfectly for us. All right, let's now solve the first problem. We don't have a connection to the database. We can write this in the application YAML, or we can do it like this. package config. Okay. In the config, we'll do something like data source.config, data source config. And in data source.config, first of all, we'll add the configuration annotation so that Spring understands that it needs to get configuration beans from here. So accordingly, we'll create the actual bean to Pablia. It will return an object of type datasource.java.rescaled. So data source, okay. And here in data source, we'll do the following. Look, return. We will return an object of type data source builder. Data source builder is parameterized, but we'll just create a method called create. And then we do the following. Look.com. First, we need a URL. We will take the URL from our starter service. Here's the pool, right over here. Oops, and let's go back. Here it is for us. The only thing is, we will connect, again, not to localhost, but we will connect to the database that will be in the Docker container. And in the Docker container, right now by the name of the Docker container. Here, at first, our database is called lib1, as we remember. And the name of the Docker container will be MySQL database library. This is MySQL database. Then we'll just give such names and that's it. All right, we have the URL. Next, mark as the user accordingly. Root. Passport 12 and then we need to install the driver. Where do we take it from? Driver class name, and we take the driver class name from MySQL. Connection string for the database uses the driver.cj JDBC driver, which is essential for establishing a secure and efficient connection. The driver, and that's it. Then we call the build method. We have everything done. Next, Spring will look for an annotation like this. Pulling out all that data from there, placing it where it needs to go. This object with the data. And that's it. You can use it easily. This is quite a thing. You can also go ahead and write it this way. This way, you can customize more using code. The next point, let's go to our controller. In our controller, we use something called Application Event Publisher. We don't need it anymore. Instead, we will need another thing. It's called RabbitMQ. First of all, let's take this one. In general, I'll explain to you later why. We only set round, and here, accordingly, we need, since it's called RabbitMQ, RabbitMQ. Here, we have it. The RabbitMQ is a core component in Spring's messaging module, providing a convenient way to send and receive messages. It simplifies the interaction with RabbitMQ by handling the boilerplate code for you. So instead of this, now it's this one. Now our piece of code will change a little bit. We'll need this object, so I'll keep it. We won't need this line. First of all, we need to create a new event by itself. Book rented event equals. And we're going to paste this like this. Control-C, Control-V, semicolon. So, just the counter. And we remove this because we won't be using the publisher anymore. Now we'll be using another thing. Next, we call rabbit.template and invoke the convert and send method. So first we pass the following there. We create an object that contains information about the rented book and send it to the RabbitMQ. But we need to understand which queue it is in. So we give a name. Let's call Book Events Exchange. Events Exchange. Okay. So next there's a field called routing key. It's just a key that is also used. Identification. Let's leave Revit for now. It will be called book routing key. Routing. This key will be used for routing purposes in the system. This key is essential for ensuring proper routing functionality within the system. Routing. Okay. We also pass the object itself here. Event. The event itself. Here you go. Everything is ready for us. So we replaced Application Event Publisher with another similar mechanism. RabbitMQ. Control-Alt-L. We're aligning. So this line can be deleted, this one can be deleted too. That line can be deleted too. All right, let's check further.
Friends, well, let's move on. As you can see, the code has changed a bit. I've added some notes here about what each annotation does, what each method does, and so on. I just moved some information here
Basically, all the code will be commented in both Russian and English, so you can download it, watch it, and figure it out. Well, of course, you need to understand it. By the way, I will have one task for you at the end, regarding what you need to do with this piece of code. Overall, it's all working. We just need to tweak a few things, and I'll ask you to do that. So what do we have left to do? We have left, since we have RabbitMQ, yes, the configurers. And since we have Rabbit template here in the controller, we need to make a configuration for our RabbitMQ. We won't dive deep into RabbitMQ configuration. That's not the topic of today's episode, but we will need to create a certain number of beans for the routing key. We'll need to create a bean for the queue and so on for the converter. Let's do it this way. We'll have a configuration class and we'll call it RabbitMQ config. Alright, since this is a config, we add the configuration annotation and then we need to do the following. First, we need to create a method that creates and configures our Rabbit template, which we use in the controllers for sending and receiving messages. So you remember, right? Our scheme hasn't changed. RabbitMQ config, RabbitMQ, RabbitMQ config. Alright, so since this is a config, we add the configuration annotation, and then we need to do the following. First, we need to create a method that creates and configures our Rabbit template, which we use in the controllers for sending and receiving messages. So you remember, right? Our scheme hasn't changed at all. So, we take the request through the IP gateway. The IP gateway forwards it to the library service. The library service processes its logic and then sends this event through RabbitMQ to the statistics module. So nothing has changed. It's just that now they're not in one place, but in different ones, as I mentioned before. Well then, let's do it. First, accordingly, we need an object of the Revit template type, public Revit template, bracket. Okay. Naturally, this will be a bean. Alright, the link is visible, everything is good. Accordingly, we create an object of the Revit template type. Revit template is probably Revit template. And here, inside Rabbit template, we need to pass an object of type connection factory. Connection factory. That's exactly what we need. Connection factory. We need this one, RabbitMQ connection. Please don't get it mixed up. We specifically need the RabbitMQ connection factory connection. This one, there was another one over there, did you see? So we pass it here. Connection factory, great. Alright, so basically what do we need to do? Turn off the damn phone. So what do we need to do? Rabbit template. Here you see it's already suggesting an option, but it's incorrect. We need set message converter. Message converter. Okay. And here we need to pass an object of type message converter, which will convert our message. Our event will be the message, so we will convert it to JSON. And since we're going to convert it to JSON, we need a message converter that handles the translation or conversion to JSON. Here we will specify a method. Let's call it JSON message converter. We don't have that yet, right? We're returning Rabbit template. I don't have that converter yet. We're returning to Rabbit template. We don't have that yet, just the converter. We don't have that method yet. We're going to write it now. Converter. We don't have that method yet, so we're going to write it now. Look, hope, create the method, JSON message converter. Please, it will return something like message converter. It will be public. This will be our bin. Okay. So return, suggest correctly. JSON message converter, please. That's it. Message converter is ready. If you watch the video on Spring Security, then it's a similar story. So we need to create some beans, pass the information there, and Spring will take care of it by itself. We're doing the same thing, but with RabbitMQ. Next, we need to create a queue, as you remember, named bookEventQueue. We have that public, it will return a queue. Let's see which specific queue it will return to us. It will return to us. It will return for us. This is the queue. Spring Framework. I'm occupé. Core queue. Take a close look at the package. Book event. I don't know. We can name it, but book event queue uyui bracket. So what are we going to return? We're returning a new queue. Yes, book event queue. You see everything is okay. We set durable to true here in order to ensure that this queue is maintained and preserved, even after restarting the Rabbit server. Alright, let's move on. What else do we need? If you've read about RabbitMQ, there's this thing called exchanges. So we need it exchange bin direct exchange. Where is it for us? Direct exchanger. Here it is for us. Direct exchanger. Direct exchange parentheses. Okay. Returning new. Direct exchange, direct exchange. But we need our exchange. So we will have booked event exchange. Exchange. Okay. And the last thing we have left is to link the queue and the exchange. This is done using binding. So there's also this object, public, it's called just that binding. All right, let's talk about binding. Here you go. Binding is what we're discussing. Okay, now let's consider the bin return. What exactly will it offer us in terms of benefits or features? Let's explore this further to understand its potential impact and advantages. It doesn't offer anything interesting, but there's something called binding builder, and it has a method called bind. We pass our queue to bind, which is the book event queue method. Next, we need to do something, which is to pass it to some exchange. This is direct exchange, please see, with some key. Look, with book. Do you remember what it was called? Routing key. So that's basically it. Looks like that's everything. Let's check the POM.xml. You see, I also updated it a bit. Library service confirmed. Starter, web, GPA, MQ, connector. Starter, web, GPA, MQ, connector J Lombok, parameter names, plugin name. Docker file, zoi erfile muchen. Docker files. Labor. Okay? If you happen to have a question about how we will link the jar file, those names that we specified, like this will be the Docker file, that will be the Docker file, I'll show you. It's basically nothing complicated. So, application.yml, well, everything is standard here, nothing new here. SQL schema, user books, yes, data.sql, okay? Everything is there, everything is okay, everything is good. Let's check. Maven, library.service, lifecycle install. Will he definitely build it for us or not? Let's indeed check. So far everything is going well as planned. So far. He has completed all the stages. Everything is working. Well, we'll see if it actually starts or not. Well, okay. We've figured this out too. Next module. So guys, statistics module, here it is. Let's see what it looks like in Monolith. What does it have in Monolith? The statistics entity, the repository, and the service. Look, we have the event listener annotation here, which takes an object of type book rented event and accordingly registers it in the database. The statistics will have a separate database. We'll make it similar to library and register that event there. Okay. What do we need? We'll need all of this. Plus, we'll need the book render event object. Right now they are in the same module and they have dependencies in the POM file, so they can see each other just fine. But since we have a microservice, we just need to create a separate entity like that. It is created simply by copying from the library. This is the first one. The second point, we will probably need to think in the service how the service will register via RabbitMQ. Well, that's it. Let's get started. Service. I can't get used to the Spanish keyboard. Next, create a new window. Let's move it here now. So guys, what are we going to add to the statistics service? In the statistics service, we'll have all the same things as in the library. So we can easily open our library service. In the statistics service, we'll have all the same things as in the library. So we can easily open our library service and make it accessible to everyone who needs it. Open POM.xml, do. Control A, Control C. Next, open statistics. Open POM.xml. Control A, Control V. But with some adjustments. Look, first of all, we already have the statistics. You see, it immediately suggests to me, it says statistics service, statistics service. So there's no confusion, statistics service. So there's no confusion. We need all the same things. All the same? Will there be conversion, serialization, and deserialization happening? Of course. Do we need Lombok? Of course. Will there be a database? Of course. Will there be RabbitMQ? Of course there will be RabbitMQ. Will there be JPA? Yes. Will there be web? Yes. Will there be a starter? Well, all the same. Here you go, it's ready. Let's update. Next, let's open the laboratory service again. Let's take the folder database, Ctrl-C. Let's go back to the statistics. Let's take a look. We pasted it into the resources with Ctrl-V. Great. Data by WCs. We don't need the TS folder. Let's delete it. We figured it out with XML. Alright. Let's move here now. We won't touch the application properties for now. Let's figure out the SQL date. We got it. Look, I made a small mistake. We need to keep the statistics. So we probably need to do it a bit differently. Look, let me delete this and take it from Monolith. That will be more correct. Now, look, I have a database folder right here in Monolith. Let's go back to the statistics. Look, I have a database folder right here in Monolith. Let's go back to the statistics. Ctrl-V. Okay, let's take a look. Alright, look, we have an insert into statistic. This part has gone into the library module. We need it. The schema, we don't need books users either. We don't need books.users either. That's it. Now let's set up the connection to the database here. We have the statistics. We also have data. Let's configure the data source plus MySQL. Everything's fine. Everything's fine. User root. Password 123. 123. I think my database is called stat1. Let's test it. Yes, that's really what it's called. Applying. Okay. Alright. Let's connect it to the schema. Stat1. I don't like it when the compiler highlights things, complaining about conflicts and stuff. I'm generally conflict free. I don't really like these things. So I try to make sure that it connects everywhere. Everything is green. Everything's good. So application properties. Application properties. Refactor rename. Oh, you know what? I'm not going to do any refactor renaming because, in fact, application properties is basically the same as in library with some exceptions. Let's just copy it from there and that's it. I'm just going to delete it from here and we'll connect in the not too distant future. And we'll actually connect a copy of library. Let's take it from here, Ctrl-C, application YAML. Let's go to the statistics. Ctrl-V. Look, it's all the same. MySQL dialect. Also the database, SQL schema. Okay. The only thing is, it's not necessary to specify the container here. You can remove it. The server port here will be 882. 882, they should be running on different ports. Well, it seems like that's basically it. There's nothing supernatural going on here. We also figured out the resources folder. Now let's figure out the Docker file. The Docker file is also very simple. Look, we are now opening the library service. Look, we are currently in it. Let's take the Docker file. Ctrl-C, and we go back to the statistics. And we paste the Docker file here. Ctrl-V, pom.xml STATISTIC-SERVICE. And the name will also be STATISTIC-SERVICE. So let's move on to the Docker file. And the name will also be STATISTIC-SERVICE. Now let's move on to the Docker file. We needed to copy the word statistics, right? Alright, let's copy statistics. Statistics. Let's go to the Docker file. Statistics. 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 That's it. The next point, we need to go back to our monolith. And here we need to go to our monolith, where is our statistics module, entity, repository, and service. Ctrl-C, let's go to the statistics. Ctrl-V, okay. The concept of entity, repository, and service pattern is crucial in software design. These elements work together to create a robust architecture. Now we will deal with them. As I mentioned earlier, we need an object of type book event. It's located in the library module. Let's go here, occasion. Ctrl-C to statistics. Ctrl-V. We've pasted it. Great. Now let's check how everything works here. So, statistics, imports. There are no conflicts here. Let's collapse this. Everything is good here. Book rented event, it's all the same. We need exactly the same object, so we aren't changing anything. Repository, you see here, that's not the right folder for me. Now we will set up the imports. Now we will do it like this. Look, start import class, alright. Let's delete it. Let's do a static import, book event import to the repository. Everything is great, it all works. The main method, what's up with the main method? The main method is also fine, everything works. So it seems like everything is okay. The only thing is now we need to do the following. We need to set up a data source, meaning a connection to our database. And where can we get the connection algorithm? Yes, of course, in the library service. We just take the config Ctrl+C and go to the statistics. We're in the statistics. No, we're not in the statistics. Where's the statistics? Here's the statistics. Ctrl+V. We moved another folder. Data source config. It's all the same, except that first of all, we won't have MySQL library, but MySQL statistic. The data will not be lib1, but stat1. You'll need to set up the database. That's it, we won't touch anything else. Let's move on to the next one. Rabbits. In Rabbit, the direct binding queue is already set up for us, so we don't really need it. We can just delete this from here. And just keep the message converter and only the Rabbit template. And here too... Oh, and what? Ctrl-Alt-O... That's it. That's it. I guess so. I guess that's everything, right? I think that's everything. Okay. I think that's everything. So friends, let's go through what we've done today, step by step. Today we created API service. The API service is a module that receives all requests and distributes them to the appropriate modules. How does he do that? Very simple. It will serve on port 8080. It will have an external and internal port like this. All messages that come to this port, if there's a prefix like this in the URL, the first part being library, will be redirected to the address of the Docker container right here. So we will have a separate library service, and we are going to write this file now. It will redirect there. Next, the following happens. Let's move on to the library service. This is just its ID. So, where is our library service? Here it is. Here is the library service.
When the Docker container is started, our application establishes a connection to its database. A request is made, the request is received. Accordingly, the logic that you all know very well takes place. So the validity is checked and it is sent to the database. So something happens. Well, in this scenario, our Rabbit template, which is a predefined format or structure used for messaging, sends a crucial message to the book event exchanger. This exchanger is responsible for handling and processing book-related events efficiently. Our Rabbit template sends a message. We have RabbitMQ running in a separate server within the Docker container. I'll also show you where it needs to go. You just need to pull the image there, and that's it. It will work perfectly. And this message is then passed to the statistics service. This is the library. I couldn't switch. Where is the statistics service? Here it is. It is passed here to the statistics. So the only thing is that I probably don't need the event listener here anymore because we're not working with it. By the way, I forgot to work on this. Look, here's what we need to do. Here, basically, it's all the same. All the same, just the annotation will be different. Rabbit template, if I'm not mistaken. Let's see. Rabbit listener, of course. And accordingly, what will our Rabbit listener be listening to? So you see, I started checking and realized that queues, that's queues, and I realized that I forgot. Accordingly, here we just need to name it our queue. Our queue is called, to be honest, I don't really remember what it's called. Accordingly, here you just need to make the title our turn. Our queue is called, to be honest, I don't really remember what it's called. Let's remember what it's called. Library service. Where is the queue? Okay, rabbit.config. Here, book event queue. Copying. Let's go to the statistics. So to the service, and here we have book event queue.
So guys, I added this little line. Basically, that's it. The data source config is ready. Our RabbitMQ config is ready. I still added the queue here. Entity statistics, application YAML. There's absolutely a standard one. Docker file, statistic-service. Exactly the same. In library service. Absolutely. Only with the word statistics. Home XML. The functionality and behavior are exactly the same as what you would find in the library service. This means that all methods, properties, and expected outcomes are consistent with those provided by the library service, ensuring uniformity and predictability. Only with the word statistic, well, let's package it into a jar and then run the docker-compose. Let's write the docker-compose.
So, let's go ahead and run this whole thing. Everything's okay. Let's move on to the next stage. So, friends, we're going to write a Docker Compose file. What is it for? We need it to bring all our modules together and have them appear in Docker Desktop. So we will have 1, 2, 3, 4, 5, 6. So we'll have 6 services. Let's see how they will look in Docker Desktop. So, please take a close look. I have a folder on my computer called ppp1, which contains our first service, the API service, the second service, library service, and the third service, the statistics service. We've set them up. I created the docker-compose.yml file. I just made the file. And let's open it using Sublime Text. It's just convenient to edit there. I've already entered the data, so let's take a look at it. Open it with Sublime Text. Here you go. Let's see what's going to happen here. Here, actually, everything is clear. So the version, note that everything comes with comments. I'll also upload this to Git, so you have it. So the service is RabbitMQ. We're downloading the image. And we're talking about what will happen with the UI. The container name is RabbitMQ. We specified it in the application YAML. Ports. For access to manage the ports, variables. In the default user guest environment, as we wrote, default path guest. We create a networks. It's called network. All right, we'll leave it like that. Let's not overthink it. Next is library database, which is the database for the library. Image, MySQL. The container name, as we wrote in application.yaml. MySQL _ library. The variable, password, MySQL database. lib1, yeah, everything's fine. Ports. Note that it forwards port 3.3.3.0.6 to port 3.3.3.0.7 on the host, which is the owner. The network is the same, my network. The statistics database, it's all the same, just the container is called MySQL DB statistic. It's all the same, the name of the database. Also ports, network. With the ports, pay attention. It's very important to know where it's coming from, what it is, and where it's going. The network is the same. Library service, do you remember what we wrote? We're passing the library service. And how do we link the jar file and the container name? Very simple. Context, library service.jar, library service. Container name, library service. Ports 81, 80, 80. Accordingly, RabbitMQ host. Note that here we are only communicating with references to the container names. It depends on RabbitMQ and LibraryDB. The same network, well, it's all the same. Statistics service. The container name is statistics service, written as one word. We link it with the jar file statistics service. Seems like everything is correct. Again, the ports are variable. This all happens inside the container dependencies. The same network and the starting module, which we call the IP service, has the container name start 8080, 80, 80, 80, settings network. They are sending it there through 8080. All the settings are here. Who it depends on, the same network, and accordingly our network. And the type of connection is bridge driver. All right, let's remove it. We're closing, and here is our library service. We're closing, and here is our library service. But before we start it, let's open Docker Desktop. So friends, here is our Docker Desktop. Let's take a look. Image, we don't have anything here. Let's go to our library service. Where is our library service? Here is our library service. Look at what we're going to do. Let's open the terminal. And now we write the command to run our Docker Compose file. The Docker Compose file should gather all our jars, upload all the images, set up the network. It should do everything by itself. Before we do that, let's check if everything is in order. So, have the library service jar. Next, we also have the statistics-service.jar, and we need the API service. API service jar. We also have the statistics-service.jar, and we need the API service. We also have it. All right, let's open the terminal. We write the following Docker Compose. Docker Compose. Next, -f, where our Docker Compose file is located. It's on disk E, // I think it's a // like this, / accordingly, our folder, where we have pp1, ppp_1. There's also the main address at the top, another /, and here we have docker compose.yml. Like this, you mean, right? Next, right now. Let's name it. It should be in some folder. Let's call it, for example, Microservice project, project like this. Next, up, and we add build
and we add double minus, build double minus. That's it, so it builds everything for us. Well, if we wrote everything correctly, if Docker Compose is all set up properly, let's give it a try. Empty compose file. So guys, I saved it again a little bit, just to be sure, and it seems like everything should be okay. A little bit more, as I always do, and it seems like everything should be okay. Here you go, docker-compose.yml, this is our file. I can show you this file. Let's add one more. In this section, we are going to discuss and elaborate on the topic of PPP_1. Here we'll put PPP_1. Okay. Alright, let us start it and begin. Now, something is starting to happen. Observe how the process unfolds step by step, just as we meticulously planned. Each phase is executed in sequence, following the detailed instructions we crafted. This ensures the application runs smoothly and efficiently. Imagine the application as a well-oiled machine, where every part must work in harmony. Our written plan acts as a blueprint, guiding the application through its operations. This methodical approach addresses every aspect, from start to finish, including error handling. By sticking to the plan, we ensure the application runs with precision and reliability. It's like following a recipe, where each step is crucial to success. Our application adheres to the script, performing its functions as intended. This strategy makes the application robust and dependable, capable of handling tasks as designed. We've got some errors. I'll tell you later, you'll need to fix this little error. I don't know what these errors are. Let's take a closer look at the situation. Please hold on for a moment, as it seems that my Docker application has unexpectedly crashed. This is a common issue that can occur during development. So, everyone, as you know, we have successfully created a Docker Compose file. This file is crucial for managing multi-container Docker applications. You can find it located in the shared folder, which is accessible to all team members. Along with this file, you will also find all the necessary modules that are required for the project. These modules are essential components that work together to ensure the smooth operation of our application. Please make sure to review them carefully. Let's try to build it.
Well then,
Is that it? It usually takes a long time to start up here for me. Let's see what we have in Docker. Images, RabbitMQ, MySQL, Project Laboratories, Statistics-Service, and Starter 1. Yes, my friends, those two containers didn't start. Two main service containers didn't start. The two main service containers didn't start for one simple reason. Because they were trying to connect to the databases simultaneously, and the database containers hadn't started at that particular point in time. That's why it didn't start them, just like any application. Let's start them up separately here. Start. And here, I'll start it separately. I want to click start here separately. Can I click start here or not? And here I am getting in the way. I'm getting in the way here. Start, let's take it back. Look, it's working, not crashing. Let's dive into it. See, it started up, everything's working. And before that, there was a connect exception. Everything's fine. And we also have the statistics service. Let's take a look. You see connection exception, and now everything is fine. Look, statistic name doesn't resolve. We've got some issues here. Let's give it a try. Let's carefully check what the problem is. An unknown host exception, statistic name doesn't resolve. Now let's thoroughly check, my dear friends. Look, I have another little mistake right here. I had this message right here, see? Sending to the target service. We definitely need to comment this out, like this, space, like this, space. Everything seems to be perfectly fine now. Everything seems to be in perfect order. Let's take a moment to ensure everything is indeed correct. Additionally, let's verify once more to be absolutely certain. Let's pause for a brief moment to reflect on the steps taken. Indeed, everything is certainly in order now. But now we need to do this. Before you begin, ensure that the environment is thoroughly clean and prepared. Proceed with the installation process carefully, following each step meticulously. Unfortunately, at this moment, the installation of the IP service cannot be completed due to unforeseen circumstances. Or what's the problem? Or is it just lagging for me because everything is running? Yeah, you know, it seems to be lagging a little bit more, you know. So it seems like there aren't any errors here. Let's check right away. I checked it, and everything seems to be fine. With our API service? Okay, good. So, look, everything seems fine, but now we have the same problem left, which is that the services start first, and then the database comes up, so the services can't connect to it and crash. I had an error because I had some lines of code that weren't commented out, so it couldn't run them later. I fixed that. Let's run it one more time. Now let's click on running, and let's see what happens. Look, as you can see right now, the process of initializing the application is happening in the background and will be ready shortly. Connection. It seems like started library service application. Thank you very much. Now let's move on to the statistics. And let's dive into the statistics. Not here. And let's dive into statistics. This one is starting up too. The statistics should connect to its database. Hikari, yeah, MySQL, that's it. The same thing. Into manager, database query, retention, localhost. Start the statistics service. Everything's fine, yeah, it seems like everything's okay. It seems like everything's okay. We're going back, and look, all our services are loaded. Here are all 6, 2 databases, 3 services, and 1 RabbitMQ server. What do we need to do now? Now we need to open Postman and make a request. So, look, here's our request to localhost 88. That's the external port. It will reach our start service, and then everything will go in sequence. Next, look, you see /library. This prefix will signal to redirect it to the library module. And then bookid1, user-id1. We're controlling the post request, sending it. Yeah. We have successfully booked the tickets for our much anticipated and thrilling event, which we have been eagerly looking forward to for quite some time. So, dear friends, we did manage to cut it after all, didn't we? It was indeed a close call, but we made it through with determination and teamwork. Friends, actually, that's it. Let's do a little summary. So we have a program. The program is divided into some logical parts. You can create a program and divide it into logical parts right away. Then you will have a multi-module monolith, and then distribute these modules into microservices. Or you can identify, for example, if you don't have modules, if you just have one big program, then you need to highlight these logical parts, turn them into modules, and then distribute these modules into microservices. Make a decision on what tools they will use to communicate with each other and actually implement it. As you can see, the distribution itself, from a logical standpoint, isn't complicated. It's quite clear. Well, in my opinion, it's clear, and here's the setup. The interaction between these modules. This is already a much more complex task. So, when we say that we're breaking down a monolith into microservices, personally, I mean it in terms of architecture, how we will do it, what tools we will use to break it down, and how we will manage it. From a logical standpoint, if you already have a module, I think there's really not much to think about there. Actually, that's it. From a logical point of view, if you already have a module, it seems to me that, in principle, there is nothing to think about. Actually, that's it. If you like the likes, if you have any questions or comments, well, we'll be releasing some more videos. I hope they will be just as helpful to you as these. Any more videos? I hope they will be just as helpful to you as these. Bye bye.